Hi, this is Tom Brower from the Hydrologic Engineering Center. In this video, I'm going to demonstrate the Gridded Data Import Wizard in HEC-HMS. The Gridded Data Import Wizard is helpful for importing data from a variety of data sources, including NetCDF, GRIB, and HDF. In this demonstration, I'm going to import MRMS precipitation data and RTMA temperature data into my HEC-HMS project. I downloaded all of these GRIB files from the Iowa State Mesonet site. So I have the GRIB files ready to go, ready for import. This is my project data directory. This is where I'm going to create the DSS files. So the first thing I like to do, you can see I have a basin delineated here. I want to clip these grids on import. And to do that, I'm going to export the shapefile of my basins. So I can do that GIS export layers, export the subbasin layer, and I'm going to pick a location on my computer. So I put my shapefile in the ctemp directory, and now I'm ready to do my gridded data import. So I'm going to go to File, Import, Gridded Data. This opens up the Gridded Data Import Wizard. This is in HMS. It looks very similar to Vortex utilities that you might be familiar with. So on the first step of the wizard, I'm going to choose my GRIB files. So I've navigated to my raw QPE directory. This is where I have all of my raw GRIB files. I'm going to select all of them on the first step, then hit next. The program is going to loop over every GRIB file and find the common internal variable to all. And in this case, it's this gauge corrected QPE is a common variable to all GRIB files, or at least all of the GRIB files I have selected. I'm going to select that variable. Now I'm going to provide a clipping data source, which is going to be my shapefile of my subbasins. The target well-known text string is the target projection. This globe icon on the right, if you open that, you can select a projection from some of the common projections used in HMS. I'm going to use standard hydrologic grid. So you can see that well-known text string there. You could optionally paste a well-known text string into this text area, or you could browse to a PRJ file. And then a target cell size. There's a number of different cell sizes you could use here. I would use something close to the grid cell size of your data. I'm going to use 2,000 meters. And then the resampling method, I'm going to use bilinear for continuous data. Now I just need to select a destination DSS file to write to. So I'm going to put it here in my C projects Punxsutawney data directory. So I'm going to put this DSS file internal to my project. And since this is the MRMS data, I'm going to name it mrms.dss. So that's the destination file. You can see I have options for selecting an A part, a B part, and an F part. So you could optionally put a string in there to name the part. And then you can see that the C, D, and E have the wildcard character. Vortex is going to be smart about the data that's coming in, so it's going to give an appropriate C, D, and E part based on the grids that are coming in. So I'm going to go ahead and start processing those grids. This will take probably a minute or so based on the amount of data I'm bringing in. Okay, my MRMS data has now been imported. I can see my DSS file over here. And now I'm going to move on to my temperature data. So I had that in a raw RTMA directory here. Going to select all of my grid files. Program's going to loop over them and find the variables internal. So that in this case, it's temperature, height above ground. I'm going to choose my clipping data source, target projection, target cell size, resampling method. And in this case, I'm going to write to rtma.dss. And I'm going to leave all of these as default. So the resolution on the RTMA grids is a little lower resolution, so the processing time is a little faster. Okay, so the import is now complete. If I have HEC DSS view on my machine, I can open up these files and take a look inside. Here's the precipitation grids. You can select all of them, graph them, and view them. So it looks like pretty intense precipitation at the beginning of the gridded record, and then it tapers off. And then my temperature data. Here's my temperature data. Looks like 12 degrees Celsius. Regardless of which unit system the data is coming in, HMS will convert to whatever your basin model or meteorologic model is specified in. So I'm not too worried if it's Celsius or Fahrenheit. So now what I need to do is I need to create a grid data object to contain the data that I just imported. So here's Grid Data Manager. I'm going to create a new precipitation grid set. I'm going to call it MRMS. And then I'm going to create a temperature grid set. I'm going to name it RTMA. So here I have my precipitation grid and my temperature grid. Now I want to use single record HEC DSS. I'm going to browse this data directory inside of my project and point to the MRMS file. Then I can select a path, and any path name selection should do. And then likewise for my RTMA grid set, I'm going to select the RTMA file, make the path name selection, save that. And now I have a meteorologic model. This gridded precipitation is looking for a set of precipitation grids. So I'll tell that to use MRMS. And then this gridded Hammond evapotranspiration method is looking for a set of temperature grids. So I'll tell that to use RTMA. I've already connected my basin model, my MEP model, and my control specifications into a simulation run. So now I should be able to compute this. And good, we've computed without errors. So we've just applied those gridded boundary conditions in our model. So we went from raw data to grids in DSS to gridded boundary conditions in HEC-HMS. This concludes the presentation on importing gridded data in HEC-HMS. For more resources on HEC-HMS, check out the HEC-HMS documentation website.